NEC Article 350.3 requires electrical conductors and equipment to be installed in a raceway, another approved enclosure, or an open wiring method. NEC Article 366.3 covers raceway systems specifically and defines them as an enclosed channel designed expressly for holding wires, cables, or bus bars, with associated fittings. When conductors are installed in trench duct or a similar trench, they are treated as if they were installed in conduit. This means they must meet the requirements of NEC Article 350. Firstly, conductors must be protected from physical damage and moisture. Secondly, conductors must be properly spaced to prevent overheating. Thirdly, the trench or raceway must be filled with a suitable material to provide insulation and fire resistance. A concrete trench by itself does not qualify as a raceway under NEC Article 366. It lacks the necessary enclosure and fittings. Therefore, it must be treated as an open wiring method and meet the requirements of NEC Article 390. If the trench cover is removable and outlets are installed inside the trench, the following considerations apply. If the cover is not flush with the floor, the outlets must be listed for use in floors and be protected from physical damage. If the cover is flush with the floor, the trench can be considered a raceway, but the outlets must be flush with the top of the cover and listed for use in raceways. In residential applications, trench duct or similar trench should be installed according to the manufacturer's instructions and in a manner that minimizes the risk of tripping or other hazards. It should also be located in easily accessible areas for maintenance and repair. The National Electrical Code, or NEC, provides guidelines for electrical installations to ensure safety and prevent hazards. When planning to use trench duct or a similar system for electrical wiring in a house, it's important to understand the relevant code sections and how they apply to this type of installation. The NEC provides specific requirements for electrical conductors and equipment. These must be installed in a raceway, another approved enclosure, or using an open wiring method. A raceway is defined as an enclosed channel specifically designed for holding wires, cables, or bus bars along with associated fittings. Examples of raceways include conduits, tubing, and other similar systems. When using trench duct or a similar trench, the conductors within it are treated as if they were installed in conduit. This means they must comply with NEC Article 350, which outlines the requirements for conduit installations. These requirements include ensuring that conductors are protected from physical damage and moisture, properly spaced to prevent overheating, and that the trench or raceway is filled with a suitable material to provide insulation and fire resistance. It's important to select conductors that are appropriate for the intended use and environment, and to follow the manufacturer's instructions for installation and spacing. A concrete trench alone does not qualify as a raceway under NEC Article 366 because it lacks the necessary enclosure and fittings. Therefore, it must be treated as an open wiring method and comply with the requirements of NEC Article 390. Open wiring methods typically require additional protection for conductors, such as running them in a protective sleeve or providing physical barriers to prevent damage. If the trench cover is removable and outlets are installed inside the trench, additional considerations apply. If the cover is not flush with the floor, the outlets must be specifically listed for use in floors and be protected from physical damage. This is to ensure that the outlets can withstand the physical stresses and environmental conditions associated with floor installations. If the cover is flush with the floor, the trench can be considered a raceway, but the outlets must be flush with the top of the cover and listed for use in raceways. This ensures that the outlets are properly integrated into the raceway system and meet the safety requirements for such installations. In residential applications, it's essential to install trench duct or a similar trench according to the manufacturer's instructions and in a way that minimizes the risk of tripping or other hazards. This may involve using appropriate covers, securing the trench in place, and providing adequate signage or warnings. The trench should also be located in easily accessible areas for maintenance and repair. This allows for convenient access to the wiring and outlets for inspection, troubleshooting, and repairs. By following these guidelines and adhering to the NEC requirements, one can ensure that the trench wiring installation is safe, code compliant, and reliable for residential use. Remember that local codes and regulations may have additional requirements or restrictions, so it's important to consult with a qualified electrician or building inspector to ensure compliance. When dealing with electrical installations, safety should always be the top priority. Always disconnect power before working on electrical circuits. Use appropriate safety equipment, and consult with a qualified electrician if needed. By taking these precautions, one can minimize the risk of electrical shock, fire, and other hazards. Considering the concerns about the rammed earth contractor potentially burying electrical boxes in the walls, using trench duct around the edges of the slab can be a viable alternative. This allows for easy access to the wiring and outlets, and reduces the risk of concealed electrical hazards. However, it's important to choose a trench duct system that is aesthetically pleasing and meets the design requirements of the house. Consider options such as hardwood covers or other decorative materials to conceal the trench and blend it seamlessly with the surrounding environment. By carefully planning and executing the trench wiring installation, one can achieve a safe, code-compliant, and visually appealing electrical system for the house. Remember to consult with qualified professionals and adhere to all applicable codes and regulations to ensure the best possible outcome. In summary, using trench duct for electrical wiring in a house requires careful consideration of the National Electrical Code, or NEC, and adherence to specific requirements for raceways, conductors, and outlets. By following these guidelines and consulting with qualified professionals, one can achieve a safe, code-compliant, and aesthetically pleasing electrical system. The NEC provides a comprehensive framework for electrical installations, covering various aspects such as wiring methods, overcurrent protection, grounding, and equipment installation. It's important to familiarize oneself with the relevant sections of the NEC and to stay updated on any revisions or amendments. Local codes and regulations may also have additional requirements or restrictions, so it's essential to consult with local authorities to ensure compliance. When planning an electrical installation, it's crucial to consider the specific needs and requirements of the application. Factors such as the load requirements, environmental conditions, and accessibility should be taken into account. Proper planning and design can help to ensure that the electrical system is safe, reliable, and efficient. In addition to the NEC, there are other industry standards and best practices that can be helpful in designing and installing electrical systems. These standards may cover topics such as wiring practices, grounding techniques, and equipment selection. Following these standards can help to ensure that the electrical system meets the highest levels of safety and performance. When working with electrical wiring, it's essential to use appropriate tools and equipment. This includes items such as wire strippers, pliers, screwdrivers, and multimeters. Using the right tools can help to make the job easier, safer, and more accurate. It's also important to inspect tools and equipment regularly to ensure that they are in good working condition. Damaged or worn tools can be a safety hazard and should be replaced or repaired. Before starting any electrical work, it's crucial to disconnect the power supply to the circuit or equipment. This can be done by turning off the circuit breaker or removing the fuse. It's also a good idea to test the circuit to ensure that it is de-energized before proceeding with any work. Working on energized circuits can be extremely dangerous and can result in electric shock or electrocution. When making electrical connections, it's important to use appropriate connectors and to ensure that the connections are tight and secure. Loose or corroded connections can cause overheating, arcing, and other problems. It's also important to use the correct size and type of wire for the application. Using undersized or inappropriate wire can result in overheating and can create a fire hazard. When installing electrical equipment, it's important to follow the manufacturer's instructions and to ensure that the equipment is properly grounded. Grounding helps to protect against electric shock and can also help to prevent damage to equipment. It's also important to protect electrical equipment from physical damage and environmental conditions. This may involve using enclosures, covers, or other protective measures. After completing any electrical work, it's important to test the circuit or equipment to ensure that it is working properly. This can be done by using a multimeter or other testing device. It's also a good idea to inspect the wiring and connections to ensure that they are secure and properly installed. If any problems are detected, they should be corrected before energizing the circuit or equipment. Regular maintenance and inspection of electrical systems can help to prevent problems and ensure that the systems are operating safely and efficiently. This may involve tasks such as tightening connections, cleaning equipment, and testing circuits. It's also important to keep electrical panels and equipment clear of obstructions and to ensure that they are properly labeled. When making changes or modifications to an electrical system, it's important to document the changes and to update the electrical drawings or diagrams. This can help to ensure that the electrical system is properly understood and maintained over time. It's also important to comply with all applicable codes and regulations when making changes to an electrical system. In addition to the technical aspects of electrical installations, it's also important to consider the aesthetic aspects. The electrical wiring and equipment should be installed in a way that is neat, organized, and visually appealing. This can help to improve the overall appearance of the space and can also make it easier to maintain the electrical system. When choosing electrical products and equipment, it's important to consider the quality and reliability of the products. It's also important to choose products that are energy efficient and environmentally friendly. Using high-quality and energy-efficient products can help to reduce energy consumption and lower utility bills. When disposing of electrical waste, it's important to follow proper disposal procedures. The electrical waste may contain hazardous materials that can be harmful to the environment if not disposed of properly. It's also important to recycle electrical waste whenever possible to conserve resources and reduce pollution. In conclusion, electrical installations require careful planning, attention to detail, and adherence to codes and regulations. By following these guidelines and consulting with qualified professionals, one can ensure that electrical systems are safe, reliable, and efficient. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you are not comfortable performing the work yourself. Safety should always be the top priority when working with electricity.